All right.
Well, welcome to another DevNation. We're going to be having a lot of fun for the next several minutes. We're going to be talking to that guy named Daniel you just saw flash up on the screen there. So we're going to be talking to Daniel Grimm. He's going to walk us through this hacking of the Istio service mesh. In other words, we're going to be using WebAssembly and doing some really interesting things by applying additional filters and things of that nature. So if you're into Istio, this is the talk for you. If you've never heard of Istio, well, this might be a little complicated because this is definitely a more advanced topic. But I want to welcome David and Hub and James. I see you on the chat there. Awesome to have you guys here. James, always good to see you. I think I see you at least 3-4 times a week, don't I? We're going to have to get together for lunch in the future when this whole COVID-19 thing is done and gone. But we're going to have a lot of fun today. I'm hoping all my streams stand up. We got every kind of network connection and connectivity going on here. So we're going to see if this stream will go forward for us. I think it's going to work out pretty well. Checking my meters. Those look like they're hitting correctly. No error messages. We were ready to go. Okay, so at this point, I want to turn over to Daniel. We're going to talk about Istio. We're going to talk about hacking the mesh. And your questions are more than welcome in the chat. I'll also give you a link to the presentation live in the chat too, so you'll have access to those slides. All right, let's go, Daniel.
All right. Thank you very much, Burr. I'll just go and quickly share my screen here. Oh, we go. Whoops. Can you see my screen? All right.
There we go.
Perfect. Yeah, my name's Daniel. I'm a member of the Istio team at Red Hat. I'm an engineer. And I work upstream on Istio and downstream on OpenShift Service Mesh, which is Red Hat's Istio distribution. And I want to talk to you about using WebAssembly to extend Istio today. So we're going to talk about, we're going to do a little recap what Istio does, what a service mesh is, how it works, how Istio performs all the stuff that it does, and how we can actually get in and change and add things there using WebAssembly. We're also going to talk a bit about why WebAssembly is a good choice for that. Just kill my noise canceling here. All right, so if you haven't heard of Istio, then you probably should read this book by Burr and Christian Poster. And if you don't want to read the book, you can also watch the Istio Masterclass, which was streamed here, I think, 10 days ago, roughly. It should be on the DevNation channel on YouTube. I'm sure Burr can put a link in the chat, or I'll do it later. So this is definitely recommended because I don't have time here to go into all the details. I'll do a quick recap, but I'm not going to go into too many details regarding Istio. So there's that. I'm going to do a bit of theory, as I said, the recap. I'm going to explain it on Envoy filters and why WebAssembly is a good choice. And then I'll go into writing filters, what languages you can use, what framework you need, how you deploy these filters. And I also have a little demo of a filter that I wrote, which is an OpenID Connect filter. And I can actually show you that in just a few minutes, and then later on we'll actually dissect this and see how it works exactly. And then at the end I have a little summary and an outlook of what's to come, both upstream Istio, but also Envoy and WebAssembly. All right, then let's get going. Well, this is kind of what you would call a service mesh, right? It's not quite a service mesh yet. This is more of a service mesh at this point. So let's imagine you have a microservice infrastructure. You have a lot of services. Two of them here are user-facing, so maybe these are web apps, and they're calling out to other services which depend on other services again. And you can already see that a failure in this system anywhere can have wide-ranging consequences, right? If a service goes down, then you suddenly could see all dependent services go down too, which is called cascading failure. And that's just one of the things that service meshes like Istio help you not just to avoid, but also to anticipate by giving you observability, so the possibility to observe your mesh, to get metrics and traces from all these different services across your infrastructure. But also it gives you the ability to do circuit breaking. So when one service goes down, you kick it out of the load balancing scheme quickly and you stop sending requests to it. Or just load balancing in general, that you have schemes to balance load across different replicas of the same service. So if you want to do all these things without a service mesh, you start implementing all this functionality into your application, right? So you have a pod, and in there is your application container. It contains your business logic. your REST service or whatever. And then you start having to add all these features to support your infrastructure, right? You have to add service discovery. Maybe you want encryption, so you have to have TLS support in all those services. You want to do load balancing, so you need some way to actually do the load balancing to select the service that you are going to route to. You want to do circuit breaking, metrics and tracing. All these things kind of add up. And you get into the situation where even though you have a heterogeneous infrastructure where you might be using a lot of different languages, you actually have some things that you want to be the same all over these applications, right? You want to behave them the same way as part of your infrastructure. So the great idea of Service Mesh is actually to take all this functionality, and instead of having to import libraries that might not even be available in every language that you're using, it just moves it to an out-of-process proxy container. So all the traffic that goes into your application first goes through the proxy, traverses through the proxy, goes into your app container, and everything that goes out of your app also goes through the proxy. So the proxy can do transparent, they can do load balancing, can take care of service discovery for you. It can actually record metrics. So for every call, it sees every call, so it can record for every call. How often has this been called? How long did it take? It can give you tracing because it's the same component in every part of the network. So it can send traces to your tracing database like Jaeger, and it can offer circuit breaking. So this is basically the grand idea of Service Mesh. You're moving all this common functionality into an out-of-process proxy container. So you're language independent. You can update it independently. So imagine you have a security problem in your encryption library. In this setup, you just have to update the proxy container. You don't have to touch your app. And also it's independently configurable. And that's kind of what the Istio control plane does, right? So the Istio control plane uses the fact that you have a fleet of homogeneous proxies that are all configured in the same way. So you don't have to configure every service according to the library you might have used, but instead you use the same proxy container all over the place, and you can configure it in the same way. So how does Istio do this? It uses the proxy, and what's Istio's proxy? It's called Envoy. It's also an open source project, and in the next slide we'll take a look at how Envoy actually delivers all this functionality. So the basic data flow in Envoy is you have a listener, and that's sort of, if you've configured Apache, then it's a bit like a virtual host or an Nginx server block, right? It just says on this interface, on this port, I want to listen. And then for every packet that comes in, you have a set of filters that are actually working on those packets. We'll get to that later. And then you have a router that can take routing decisions based on what the filters have actually seen. And then you route it to a cluster. And then you even have another possibility there on outgoing packets, basically to apply another set of filters. So what do these filters do? Well, they can basically do everything with your traffic. And it's an extremely powerful and adaptable design, even though it seems kind of simple. So how exactly do we set this up? We have in Envoy, we have a listener config where you define, as I said, the interface and port, and then a set of filters. You have a route config where you actually define routes, like for example, /auth should go to the Keycloak cluster. And then you have the clusters where you say, okay, the Keycloak cluster is reachable under this IP and this port, and every traffic that goes to this cluster has to go through these filters. We're going to focus on this part, on the listener filters, or it's actually listener filter is another term. So the filters that are part of the listener, and not so much the filters at the cluster level, because those aren't used as much and they're fairly new. They've been added, I think, roughly a year ago or 1.5 years ago to Envoy, and they're not used as much because the incoming filters are already so powerful that you don't really need them that much. So let's take a look. Generally, this is the very simple model that if you can't follow me on the next slides, this is really what you need to understand about how filter chains work in Envoy. basically you have a set of filters, filter A, B, C in this case, and the incoming request goes through A, B, and C, and all these filters can read and potentially even write to the traffic, and then it's routed to the service that you want to route to, and on the way back you go to C, B, and A. And that's a very simple model that you can use to understand the filters. In reality, of course, it's a bit more complex. You have 3 different kinds of filters, where you have the listener filters that act on raw binary data. So basically, really what's in the TCP packets, not the packets themselves, but the payload. And the network filters also look at raw binary data, but the listener filters are more about the connection establishment. And when you have an established connection, the network filters kick in. And the network filters will then look at the traffic. If you're using TLS, for example, the network filters will look at decrypted traffic, whereas the listener filters will actually look at the encrypted traffic. So for them, it's just going to be all gobbled up. But you need those listener filters to actually decide what filters to use after that. So as I said, it's not quite as simple as the ABC filter, but I'll get to that in the next slide. So the last kind of filter is the HTTP filters. Those are filters that act on the layer 7. So they already have an understanding of HTTP requests. So they're like the highest level that you have in Envoy. And as an HTTP filter, for example, you can do things like give me all the headers, or give me the header with this name. Write this header to the request. So it has an understanding of the semantics of HTTP and doesn't look at just binary data. So how it really works is this. The listener filters are basically the ones that are used first when the traffic comes in, and they can do things like read from the encrypted TLS stream. They can, for example, read which host name was this supposed to go to, because host names in TLS using SNI are sent over the wire in plain text. This helps proxies and edge proxies in general to actually distinguish where to route the traffic, even though it's encrypted, right? They also have to decide which certificate to use to decrypt the traffic, because we often have situations where one server manages multiple domains, and they then have to know those domains have different certificates, so they have to know which domain do you want to talk to, so it can actually decrypt your request. So that's what the listener filters can do, and those then decide the information that the listener filters get from the connection can then be used to match a filter chain. So you can match on the host name, for example, as I said, and in this case you would then say domain A goes in the top line, and you have a set of network filters that you apply there, and you know certain things about the traffic. Let's say domain A and domain B, these 2 lanes here, are both HTTP traffic, but in domain A you have XML data coming in, and in domain B you have JSON data coming in. But you want to route them to the same service which only understands JSON. So in domain A, you have XML data coming in. You could use an HTTP filter to actually convert this XML data into JSON before you send it to the service. And here you would then not use this filter because it's already coming in as JSON. You could then just use a JSON validating filter, for example, to make sure that the request is valid, or it's valid JSON. So this, just to give you an idea of how powerful filters are, and this is actually how it's also used in production. So people are using it to, for example, migrate their backend services from JSON REST services to gRPC, and they don't have to, have a migratory phase where the service can speak both. They just rewrite the service to use gRPC, and then add an Envoy filter that translates from JSON to gRPC, and it's done. It's transparently done. They don't have to change anything about how they run the service. They can just migrate like that. And there's actually an Envoy filter that does exactly this. So this is not just an example. This is something that's been done in production by the inventors of Envoy, by Lyft, because they wanted to do exactly this migration from JSON services to gRPC services. So there's multiple ways to write filters. The first and most obvious way is to just use C++ and compile your filter into Envoy. So Envoy by default has a set of filters. As I said, this gRPC JSON transcoder filter is, for example, is compiled into Envoy. So you could always go and write a filter in C++ and compile it into Envoy. The problem with that is compiling Envoy takes a long time. On my machine, which is fairly powerful, it takes roughly 1.5 hours. And that's the long turnaround time. If you want to, if you're experimenting with building something, then you don't want to have turnaround times like that. You can, of course, optimize this with caching, but there's other problems with it, right? You don't want to be rebuilding your proxy because you could make mistakes and have security issues and all this kind of stuff. So ideally, you want to use a proxy image that you trust and then just add a filter to it with a specific interface. Another option is to use Lua. Lua is a scripting language, but Lua support never got further than just writing HTTP filters in Envoy, and it's not quite. It doesn't feel like really programming, right? You have to actually import text files, or you have to inline the Lua script in your Envoy configuration, and it is quite powerful. And up until recently, it was a way that was used by a lot of people to write filters for Envoy, but it never got past a certain point, and it kind of stalled. So what a few people, especially in the Istio community, started doing was investigating WebAssembly to write these filters. So why would you look at WebAssembly? There's a few things why it's a great choice, and one of them is that it's near native speed, depending on the runtime that you use. You have like 50 to 80% of native speed, which is pretty good for bytecode language. It's language independent. As I said, it's bytecode, so theoretically you can compile any language into WebAssembly bytecode. It doesn't support garbage collectors yet, but as soon as that's there, I expect also languages like Java or Python to be ported to WebAssembly so that they can produce WebAssembly modules. And it has a lightweight isolation model. And I don't quite mean this in the way that Docker containers are more lightweight than VMs, for example. It's kind of a different angle because in WebAssembly, a WebAssembly module by default is basically an empty hull, and it doesn't have any sort of interfaces to the operating system, right? Everything that you want to make available to the WebAssembly module, you have to explicitly allow. So WebAssembly modules can say, I want to import a function with this of this type. It has these parameters, it returns these parameters. But a WebAssembly module can never just open a file or start a process or write to standard out. That's just not part of WebAssembly. WebAssembly is really just the bytecode format and a way to define the ins and outs of your module. So while there is work to have a WebAssembly system interface, it's not there yet. And also, it was invented for the web, right? So it wasn't meant to be just opening files on your computer from the beginning, right? It was built with security in mind. The idea was it can't do anything outside its sandbox by default, and everything that you allow it to do, it then can do. But by default, it can't really leave its sandbox. So there's this quote by Solomon Hykes, who was one of the founders of Docker, that often comes up in presentations about WebAssembly, because he says if WASM and WASI existed in 2008, so WASI is the WebAssembly system interface I just spoke of, we wouldn't have needed to create Docker. That's how important it is. So here you can see that, take it with a grain of salt. I'm not sure, he's definitely a proponent of the technology. I definitely am too. I'm not sure it's unnecessary to have Docker, because for me, they operate on different levels, but that's another discussion. That's just so you see that this is not some fringe technology, right, that was adopted because it sounded cool, but it's actually a lot of really smart people think this is a good technology, and there's a lot of really smart people working on it. And that's actually another reason why it's a good choice. It's an open standard developed by the W3C. There's an active community with various runtime implementations. So Mozilla has spent a lot of work on their own, which is called CraneLift. There's WASM. Chrome has built WASM support into V8. And last but not least, it radically simplified filter development for Istio devs. Because Istio uses, so most of Istio's functionality comes from Envoy, like I said, but some of it isn't there yet, or wasn't there when Istio started. So Istio has some custom filters, and how they get them into Envoy right now is they actually have their own build of Envoy. They actually have to compile them into Envoy, which is a lot of work. As I said, it takes a long time to compile it, and it's much harder to compile the whole package every time instead of just having to compile your little WASM module that you then can plug in during runtime, by the way. It doesn't have to be there when you start Envoy. So it's much more work to maintain this tight integration with Envoy that they have, and they would much rather just take an off-the-shelf version of Envoy and just throw their plugins at it. It's for Istio developers, it's much easier too. So at this point, I'll just quickly show you how this stuff works. Let me see. I have, I'll zoom out here a little bit. I have a running kind cluster here with Kubernetes 1.18, I believe, with Istio 1.6.7 that's running, and I'm running a Keycloak instance, and I'm running an HTTP bin instance. So just to show you how this filter stuff works, I'm gonna do a quick port forward because I don't have a proper load balancer here to the Istio Ingress gateway. Oh. Oops. There you go. Now, go to that domain. Oh, we're already getting, I forgot to remove the stuff. So I already have my filter in here. I'm removing that real quick. And I'm also removing this. Go. So now I just have Istio and an HTTP bin, and I'm using the Istio Ingress gateway to route to this HTTP bin service. So this doesn't do much, right? This is just, most of it is returning the request. So this is actually my favorite endpoint. It just returns the headers that you sent to it. This is pretty simple. I'm not using any of Istio's functionality at this point. But what I can do is I have, if you look at this thing that I just deleted, I have a request authentication object here, which means that it matches on the HTTP bin service, and it's adding a JWT rule, which means that Istio will now try to validate a JWT token for this app, for this service, and the token has to be issued by this issuer, and the keys to validate the signature of the JWT is here. So that's the Keycloak instance that I'm running as well. So basically this means nobody can use HTTP bin unless they have a token from my Keycloak instance. And then I have another authorization policy here, which just means you've got to have a principal, meaning you've got to have a token. Otherwise, there's this weird gap where if you don't send a token, this is going to go through, but if you send a token, it's going to validate. It's going to not validate. So this makes sure that it also requires us to have a token. This makes sure that if you send a token, it has to be signed by this authority. So if I apply this, let's see, we can see that the endpoint that I like so much is still available, and now not anymore. RBAC access denied. Why? Well, I'm not sending a token, obviously. So that's the problem here. I don't have, as a user, I have no idea. I know I built this thing, so I know that under auth I can find the Keycloak instance, but that doesn't help me in getting a token. That's an API thing, right? How do I get a token? So this is actually the JWT functionality that's offered by Istio, and the missing piece is doing the redirect and all the stuff in the background to actually fetch the token and attach it to your request. And that's what I built in my filter. So if I add my filter, and we can take a look at that as well. So this is an Envoy filter resource, which adds, this is my configuration for the filter, but mostly it says, insert my filter before this filter. And this is the filter that Istio uses to validate the JWT. So I'm injecting myself right before the JWT validation so that I can actually fetch the JWT and add it to the request so that the validation doesn't fail. So let's take a look. It should be applied now. We go to the same endpoint. We're forwarded to Keycloak. So I know, because all good instances of Keycloak have admin as username and password, I know that that's how to get in using that. And suddenly I can see the page again. And the only remnants you see of something happening actually is this cookie. So I'm storing the access token in the cookie. And you can then go actually, this is pretty zoomed in, and you can go to a site like JWT.io and parse it. Works. So now you see this was actually issued by my Keycloak instance. Audience is test. This is what I'm using to test, obviously. And yeah, so this is the token from Keycloak, and that's why it's accepted. And this was all done transparently. I didn't have to do anything. In fact, the tokens expire after a minute, and I don't even notice. Like, it's probably expired by now, and I'm using a different one because my filter is automatically refreshing them if they expire. So the cookie lifetime is the same as the token lifetime. Okay, so let's go back and see how that works. Where's my browser window? Here we go. So, writing filters, how does it work? There's the proxy WASM spec, which you don't really need. It's the bytecode spec, if you will, that defines the WebAssembly functions that are offered by the proxy runtime and that you can call from within WebAssembly. But because you're not writing bytecode yourself, I hope, I mean, you might want to, but I hope you don't, you're probably much rather going to look at the SDKs available for C++, Rust, Golang, and AssemblyScript. And the first two are official, and the last two are third-party. And I think I put them in the order of best support. I think C++ is the most feature-complete. Rust has a few rough edges. Actually, for my filter, I had to use my own fork because I couldn't get config reading to work. Golang is problematic because it only works with TinyGo, which is a version of the Go compiler built on LLVM. And TinyGo only supports a subset of Go, and then compilation to WASM is again a subset of that, and then you end up with, I don't even know if this code is going to compile. So I tried using Golang because I like Go, but I got stuck at some point because I tried to parse JSON and I imported a library and I couldn't get it to work. I tried another one, couldn't get it to work. And after library number 5, I kind of gave up. There's the AssemblyScript one, which I haven't looked at in a while. Back when I tried it, I couldn't really find any libraries for it. So I couldn't find anything, for example, to parse JSON. So I didn't go with that, but I think that's another good option. And it's built by Solo.io, who are also very active in this space. And the deployment of the filter basically works currently by copying the WASM file. I'll show you quickly. So basically you have, let's go this for a moment. When I build, I get this file. And it's pretty big. I don't know, I think Rust puts a lot of its standard library in there. So basically it's just this file that you have to copy onto the proxy, which I did previously. And then you can reference it in the Envoy filter file. So here you see I'm referencing a file that I put there previously, which of course it's not ideal, right? You have to actually put this into the container somehow, and but that's being worked on. So this is still very early days, I got to say, for this technology. So that's how you deploy it right now. There's also, if you're using WASM by Solo.io, which is another way to develop these filters, they have a nice way. They have a debug command, I think, where they just run an Envoy instance locally. So here are some links to the SDKs. As I said, I used Rust and I can recommend it. I had to I had to fix some things to actually get it to work, and I still have an open PR. I hope it's going to get merged. But if you're into C++ and you like Bazel, which I hate, you might want to try the C++ SDK. As far as I know, C++ is the most feature complete, and you probably going to have the least problems using C++. But then again, I thought I'm doing this because I don't want to use C++, so why would I then go back and anyways, it's your choice. I'm hoping that there's going to be a lot more languages coming into this list soon. So when you write a filter, one concept that is probably the same across all SDKs, as far as I know, is that of context and root context. So this helps you to manage state for your filter, basically. So you have a root context that's initialized once for every thread of your filter. You should keep in mind not just once, but once per thread, and there's a lot of worker threads. And then you have a context which has the same lifetime as a request. So basically, context is created when a request comes in, and when a response is out, context dies. So context is kind of the place where you can store things for the lifetime of the request. If you don't want to share it to other workers, because a request is bound to a worker. If you want to share things across workers, so if you have a few ways to share data between instances of your filter, but also with other filters. There's actually things like get shared data, set shared data. What I'm using is dispatch HTTP call, because for OpenID Connect, you need that to actually retrieve the token. And on HTTP call response is the equivalent to then actually read the response. That's why I need JSON as well, because the response is in JSON. And on the HTTP context, you have things like here, this like the callbacks. When the request headers come in, then you can do something with it, and you can return an action. Action is basically just stop here or continue. So you could read a header and see, okay, what I'm doing in the code, actually, we can take a look, is when I read the headers and there's already an authorization header. It's kind of my first thing. On request headers, so if it's not authorized, so let's go down. If it's authorized, I just say continue. So that means my filter doesn't do anything. And is authorized is really just a call that checks whether the authorization header is set. So I basically just look at the header and say, okay, if there's already an authorization header, you're probably trying to use your own token. In that case, I'm not going to interfere with you. But if you don't have one set, then I'm doing all this other stuff, right? I'm checking for the cookie. If the cookie is not there, I'm checking for a code that I get after redirect. If the code's not there, I then redirect you. And that works by sending an HTTP response and saying action pause, because I want to avoid the request going further through the filter chain. It doesn't need to. I already know that this is the definite response. The response is going to be a 302 location. This is the auth server. So you don't have to go through all the other filters and actually be routed to the service, because I already know you have to be redirected. So that's what you use the action pause for. Yeah, and I think I'm going to quickly show you how OpenID Connect works, so you see a bit more about how I wrote this. So the flow is basically a user goes to your proxy, or it tries to access your service, right? And the proxy redirects the user to the authorization server. We've seen that, the login screen, right? And then the user logs in. Authorization server then redirects you back with a code in the URL. And the proxy then can read that code. And then we'll send another request to the authorization server to exchange that one-time use code for an access token. And then gets back an access token, writes it to the header, and moves on with the request. And then the user can use the service and doesn't even know that there's something in between. In fact, I think my session should be there still. Oh no, I stopped forwarding. That shouldn't be an issue. Yeah, so my token has changed. I can't check it because I don't remember what the old one looked like, but it has a lifetime of 1 minute. So it's definitely changed, but it's been automatically refreshed. And there was a redirect to the authorization server, which actually gave me a new token. And that's all transparent. So yeah, that's kind of what you can do with these sorts of filters. There's all kinds of other use cases, of course. You can do way more. As I said, you can transcode different formats, and with the cluster filters, when you can transcode on outgoing requests, you can do funky things. Like I've seen someone trying to do an Envoy AMQP filter set where they have an incoming filter that translates AMQP to HTTP, and then an outgoing that translates it back so that you could replace the HTTP transport with an AMQP transport. So there's a lot of possibilities. You can build all kinds of failure detection mechanisms, or just a simple old distributed system for banning IPs, for example. You could have a very simple filter that just reads from a Redis instance periodically, because you can also do periodic jobs as a filter, that reads from a Redis instance which IPs are banned, and every request coming in from those is banned, or which JWT is banned, and all these JWTs will not be accepted anymore. So you can augment the features of the service mesh and have like standardized functionality in your proxy, and you don't have to touch your services, and they get all that for free. And yeah, I think that's mostly it. How are we looking with time? Actually,
we're a little bit over, but that's okay. We actually have an interesting question, and I'm going to do my best to try to articulate it, because I've been debating it here with OK on the chat, and he wants to use Istio Security, right? So he wants to use Istio for authentication authorization and basically apply, have that be the security model, if you will, for his application. He has a React front end and a Java back end. So React.js on the front end, Java back end is what it looks like there. And so how would this technology help him secure his application from the front end, running out in the browser in React.js, all the way through, to the service, in this case, running on the cluster, running inside that service mesh? And then he uses Keycloak to get his, JOT token, JSON Web Token.
Mm-hmm.
So how would you kind of blend the Istio security model, authorization model, with a WebAssembly-based filter, with Keycloak, right, to secure that React application all the way through to the back end?
All the way through to the back end is the interesting part, I guess, because you can use this stuff, like this filter that I wrote together with Istio's JWT, to secure the front end. What I showed here is basically how
securing the front end.
Right. So you can secure an application. It also, if the backend is under the same host name, it will also send the JWT to the backend. So all the calls from the user side to your proxy will basically contain the JWT, and then the proxy will check. So yeah, you could definitely do that. I would, though, recommend that if you're writing an application from scratch, you'd rather put that into the application itself and actually do change the application if you're writing it yourself, because then you also get to do other things like parse the JWT and have user groups and things like that. What I showed here is really useful if you have something like Elasticsearch, for example. They have this really stupid open core model where you get Elasticsearch, but you don't get authentication for free. You have to pay for it. So a lot of people came up with solutions to actually put a proxy in front of it and secure it using stuff like this. For those things, you can use this. But so what for example, in my setup here, what doesn't work is when the token expires and you send an AJAX post request, that will actually be redirected, and the browser is smart enough to then refresh the token and do all this stuff, but it doesn't come back as a post request. So especially for like React applications, this is probably not the best solution, because you'll have this weird instance of if the token has expired and then the user clicks a button that triggers a post request, it won't work on the first attempt, but then on the second it will. So I already have an idea on how I can fix that, but it's not really. I don't think it's good behavior from an HTTP server. So yeah, as I said, I think this is like a drop-in solution if you have an application that absolutely doesn't support authentication. If you're building an application from scratch that you could put OAuth support into, then I'd rather do that because there's a lot of libraries to do that.
Well, you could integrate.
For Java, definitely.
You could have Keycloak integrated directly, right? Without Istio,
right.
without. Okay.
I mean, Istio still gives you the encryption between services, for example, and additional security because you can define which service can talk to which other service. But if you're really just looking to secure one front end and one back end, Istio might also be too big of a gun for you. It's more meant for really big architectures, right? And it plays out its
microservice architectures.
Right. Right. I mean, big in the number of services big, not services themselves big.
Right. So if you had backend 1 talking to backend 2, talking to backend 3, talking off the mesh to something else and back into the mesh on backend 4, that's where an Istio really shines, right? And something really shines. If it's just simple 2-tier architecture, front end, back end, might be overkill in this case. So hopefully that answers OK's question. And OK, you can tell me in the chat if we came in close to the world you're interested in. He was wondering maybe, do I even need Istio maybe for this use case as an example, or and WebAssembly filters and all that stuff. And then
the honest answer to do I even need Istio, I think, is a lot of times is no. You have to be careful what you get into. It's a big thing.
Right. And if you and then another question from Peter was, can I get this demo code? He liked the demo code. Is it out on GitHub anywhere?
Yeah, it's all on GitHub. I forgot to put the link into the slides. I
tell you what, chat it with me on the Blue Jeans real quick, and then I'll pop it over to the other folks on the chat. Yeah, but that's fantastic. Any other questions from the audience while he's looking around for his GitHub repo where we can kind of check that out? It was actually a pretty fun demo, though. Thank you for that, Daniel. I enjoyed it. Very cool.
I enjoyed it too. So this is the right link. There you go.
All right.
Yeah, and that repository contains everything. Contains the filter code, and there's an example directory with a deploy sh script, and you just run the script, and it sets up if you have kind installed and istio-ctl version 1.6 something, it will just set everything up for you, and then you have this exact same demo that I showed you.
All right, that is very cool. Well, I think we're out of time for today. We addressed the tough questions there, and we got the code out to everybody that wanted it. So if you guys have more things, feel free to follow up with me on Twitter. You can find me there. Everyone here, if you're on a Tech Talk, you have my email address because I'm the guy who sends you the email to let you know the next Tech Talk is coming. Daniel, thank you so much for your time today. Everyone has the slides. They can follow up with you too. So that was fantastic. I enjoyed it because it's always fun to have a real deep dive topic where you're trying to do some really hard stuff. Thank you so much, Daniel.
Thank you.
And for everyone else, we'll see you next Tuesday for the next DevNation show. You guys should be ready for it. We have a new special guest, and we're going to have a new game for you coming up on Tuesday. And, of course, we'll be back here doing our hardcore tech talks on Thursdays going forward. And don't forget, we have a very special DevNation Day coming up on September 15th. So lots of cool stuff coming your way on DevNation. Just be prepared for it because we're going to have a lot more fun as we go. Thank you so much, and we'll see you guys later.